I'd like to talk about netlists for circuits, and at the same time I'm going to expand a little bit for people having trouble recognizing when elements are in series and parallel.
We looked earlier at this circuit which had a bunch of resistors in series and parallel, and I want to go through it again because I want to say some more about different methods of recognizing series and parallel components. And I started by saying last time that you could identify the nodes in a circuit, and I kind of see this without having to draw a little mark around it, but then I've been doing this for a lot of years. But if you're in any doubt, it's a good idea to just draw in, to identify each of the nodes. And then we said that series components could be recognized as series components because they were both joined to a node, and that node went nowhere else. So I looked at this node here and I said, look, there's only two branches connected to that, and those two branches must be in series. Likewise, if you get a case where you've got, say, two nodes here, and you have two elements, R4 and R5, which are connected to those same two nodes, that you knew R4 and R5 were in parallel. Is there any other way of recognizing series and parallel? Well, yes, there is. For recognizing parallel components, it's possible if you can draw a line in a box. So you have a closed loop, and that closed loop goes through two and only two branches, then those two branches must be in parallel. You can probably see geometrically that's the same thing as saying that these two branches connect between the same pair of nodes. They form a little box. And the dual of that for recognizing series is if you can draw a loop around two components, and there are exactly two components inside the loop, and there are exactly two spots, only two connections, where the outside world connects to the things inside the loop, then those two guys must be in series. And you can see that's pretty much geometrically saying the same thing as the rule I did with the green pen here, where you had a node that was connected to two and only two branches. There is one other method, and this is the method that computers use, which I will explain, although, and I've seen people using this methodically in exams, but I think this is rather too long and too silly for humans, but we'll try going through it anyway. A computer numbers the nodes. So let's do exactly the same thing. We'll say that's node 1, and I typically draw a little symbol like that to indicate that. I'm going to call this one down the bottom node 0 because in electronics we usually call the largest and ground reference node node 0. Computer programs invariably do that. And then I'll label the other nodes here. Let's call that node number 2, and let's call that one there node number 3. Once you've numbered the nodes, it's possible to effectively capture the circuit in what's called a netlist format. And what you do is you write each branch. So let's start with R1. And you say R1 it touches node 1, and it touches node 2. And now R2, see here goes between node 0 down here and node 2 up there. So R2 connects between 0 and 2. I'm drawing my zeros like a computer does so we don't get confused with O's. It's not an issue here. R3 is connected between node 1 and node 3. R4 is connected between node 3 and node 0. and R5 is connected between node 3 and node 0. Okay, so now you see I've listed all the branches in the circuit. There's the voltage source as well. I could be complete, and I could put him in there as well, and he goes from node 0 to node 1. So the rule that a computer uses in this circumstance, he goes through this list, and being a computer, he's very methodical and numerical, and he says to himself, if I can find a node number that occurs only twice, then there'll be two things in series connected to it. So I see here that the digit 2 occurs only twice, doesn't occur anywhere else in the list. Because the node 2 occurs only twice, I know that the two elements connected to it are in series. And lo and behold, I get the same result. R1 here and R2 here come up as being in series. And the rule for parallel is that if the same pair of node numbers occur on two different branches, they must be in parallel. And I observe that I've got a 3 and a 0 there, and I have a 3 and a 0 there, and therefore these two components, R4 and R5, must be in parallel, and lo and behold, that is exactly the result that I got before. And so any of these three methods is valid. Like I said, I kind of see the green node method as soon as I look at a circuit, and that will come with very little practice. But in the meantime, any one of these methods will help you recognize and check series and parallel.